Welcome back. This is 7.6 notes, which is factoring by grouping. So let's quickly review as our warm up. How do we factor something like this? 20x to the fourth plus 10x squared. We look at our coefficients, 20 and 10, and we say, what is the greatest common factor in 20 and 10? Well, 20 is 10 times 2, so I can factor out a 10 out of both of those. And then we look at the variables. So if we have x to the fourth and x squared, we look at our smallest exponent. We can say I can factor out x squared out of both of those. And then we say, what are our missing pieces? Well, we said 20 is 10 times 2, so we need a 2 here. And x to the fourth is x to the second times x to the second. Okay, then we do a plus sign for our next term. 10x squared times what makes 10x squared? Well, I already have the whole 10x squared, so we just need a 1 as a placeholder. So that is factoring using our greatest common factor, GCF. And that's what we're going to be doing when we factor by grouping. So this will be that's why it's a good skill to practice right before we get to grouping. So when do we use this? We use this when there are 4 terms. So when we have 4 terms. That's the important part, guys. 4 terms. So if you see 4 terms, you know we have to do factoring by grouping. So here are our steps. Step 1, always check for GCF. If there's a GCF there, that's going to make your life easier to factor it out first. Then this is called grouping. We're going to group into groups of 2 terms. We're going to find the GCF for each group, factor those out. Find the GCF for the entire expression. We're going to look at the parentheses when we do that and factor it out. And that's it. All we're doing is GCF grouping or GCF factoring, but we're doing it in groups, which is why this is called grouping. So let's do our first example down here. So we have example A. We have 1, 2, 3, 4 terms, right? So that's how we know that we're going to be doing grouping. So check for a GCF. Well, they don't all have a variable. And let's see, 20, 12, 15, and 9. I know 9 is 3 times 3. And while 15 and 12 are multiples of 3, 20 isn't. So I don't think we have a GCF. So let's skip to step 2. We're going to group these up into sets of 2 terms each. So now we're going to find the GCF for each group. So our first group is 20x to the third minus 12x to the second. I'm not worried about the second 2 terms right now. We're just looking at these first 2 terms right here. So what is the greatest common factor of these 2 terms? Well, 20 and 12, you might think 2, but there is a larger one. They're both multiples of 4, right? So we can factor out a 4. And if I look at x to the third and x squared, I can factor out x squared. So let's see what we have left. 4 times what makes 20? 5, and x squared times x makes x to the third. Bring down your minus sign. 4 times what makes 12? 3, and we already have x squared factored out, so we don't need any more x's. Okay, whatever sign we have in the middle, we're going to factor that out. So now I'm going to look at 15x and 9. They are both multiples of 3, so I'm going to factor out a negative 3 from both of these. So this is where the signs do matter. So we're going to think negative 3 times what makes 15x? Well, I'm going to need a 5 to make the negative 15, and I need an x to make the x. And then negative 3 times what makes positive 9? Well, negative 3 times negative 3 makes positive 9. So now look at what we have here. Look at these sets of parentheses, 5x minus 3 in both of them, right? So that is going to be my greatest common factor, is 5x minus 3. What am I going to have left over? Everything that's not in the parentheses. So 4x squared minus 3. And that is my factored answer, right? These are 2 polynomials being multiplied together, right? It looks just like our multiplication problems, but it's the end result of being factored. Let's do another example. Okay, same idea, right? I have 4 terms here and I don't have anything in common because I have variables and then I have a number. So there's nothing in common, so we're going to group them up. And we're going to look at our first 2 terms. X to the third plus x squared have x squared in common. Okay, so if I take out 2 x's, I have 1 left over, and if I take out both x's, I have nothing but a placeholder. Okay, we have a plus in the middle, so I'm going to bring that plus down. And we're going to say, what do x plus 1 have in common? Well, not really anything, except we have said that we always have this 1 in common. So we can always factor out a 1, and but we usually don't. Here's where it's going to help us, right? Because we're going to need that in our next step. So just like before, we should have parentheses that match, right? So x plus 1 is my first set of parentheses. And then we have to look at what's left over. Our leftover stuff is x squared, and here's where that plus 1 is really helping us out, because we need to have that as part of our second set of parentheses. And that is our finished factored form answer. All right, we just have some more practice to do. Our next example is C, and the process is going to be exactly the same. We're going to look to see if we have anything in common in all of these terms. So do we have any variables in common? No. Do we have any number coefficient factors? Let's see, 6 is 2 times 3, 9 is 3 times 3, 4 is 2 times 2. Right there we know we don't have anything in common. Okay, so now we're going to group into groups of 2, and that did not work out well. So group 1 and group 2. So in our first group, 6x to the third minus 9x squared. 6 and 9 are both multiples of 3, and we have at least 2 x's in both of those. So we can factor out 3x squared. Think about what we need to multiply back. So 3 times what makes 6? 2. X squared times what makes x to the third? X. And we're going to do the same thing with the next term. 3 times what makes negative 9 is negative 3, and I already have my x squared. Then we look at our second set of terms. We bring that plus sign that's in the middle down. Whatever that is, that's always what we factor out. And then we look at 4x minus 6. They're both even. They both have a factor of 2, right? 2 times what makes 4x? 2 times 2x makes 4x. And 2 times negative 3 makes 6. So now is where we look, and we hope we should have matching parentheses, right? So that's going to be one of our factors. And then our second set of factors in our second set of parentheses is going to come from the 3x squared and the plus 2. And we just copy them down just as they're written, just put them in parentheses. And that is done. We're moving on to our next example. Okay. Example D, same idea, right? 7x to the third minus 4x to the 4x squared minus 7x plus 4. So 7 and 4 obviously don't have any factors in common. So all I'm going to be able to factor out here is going to be the x's. So I'm going to factor out x squared, leaving 7x minus 4, right? I just took out 2 x's from each term. Now the second set of terms here, right? 7x plus 4. We got to factor out a minus something, right? We have to factor out that minus sign. But they don't really have anything in common. So when they don't have anything in common, I'm just going to put a 1 there. So we're going to factor out a negative 1. So negative 1 times what makes negative 7x? Well, it has to be positive 7x. And then negative 1 times what makes positive 4? Negative 1 times negative 4 makes positive 4. So again, now we should be with matching parentheses, right? So that's going to be our next greatest common factor. They both have that set of parentheses. And the leftovers are x squared minus 1. X squared minus 1, and done. Okay, last example for this section. Okay, now this one, so this one starts with x to the 5th. Everything else we did started with x to the 3rd. So this is kind of telling us something. Maybe we actually do have a GCF here, right? So we're going to check for that GCF. So I'm noticing just x to the 5th, x to the 4th, x to the 3rd, x squared. They all have x's. So we're definitely going to be able to factor out x squared. But now if I look at my coefficients, 12, 4, 42, and 14. Is there anything that we can think of that goes into all of these coefficients? Well, 12 and 4, could be 4, but if I look at 42 and 14, 4 doesn't go in there. So they are all even, so I'm going to be able to factor out a 2. And that's going to be our first step. We're just going to factor out 2x squared. So think about dividing each of these by 2, right? Divide by 2, divide by 2, divide by 2, and take out 2 of the x's. So 12 divided by 2 is 6. X to the 5th divided by x squared is x to the 3rd, right? It's 2 less because that has to go back to our exponent rules. So our second term, 4 divided by 2 is 2. X to the 4th, take away 2 is x squared. 42 divided by 2 is 21, and x to the 3rd, take away 2 is just x. Plus 14 divided by 2 is 7, and then x squared, I took away all those x squareds, so we don't have any more x's. Now, this set in our parentheses looks more like what we're used to factoring. So now we're going to do factoring by grouping. So I'm just going to kind of ignore the GCF for a minute, and we're just going to look inside these parentheses. So 6x to the 3rd plus 2x squared. They're both multiples of 2, and they both have an x squared. 2 times 3 makes 6x to the 3rd. X squared times x makes that x to the 3rd. And here we have 2x squared. We factor out 2x squared, so that's just got to be a plus 1. And we're going to do the same thing over here. We have 21x plus 7, right? So those are both multiples of 7. We have to take out the plus. Okay, so we factor out a 7. 7 times what makes 21x? We need 3x. And 7 times what makes 7? We just need a 1. Okay? So now I'm just going to put this all kind of in big brackets and put that 2x squared on the outside, that GCF that just kind of comes along for the ride. Otherwise, we're just doing factoring by grouping inside these parentheses. This is as tricky as these get. Okay, so last thing we do here, right, when we have parentheses that match, that's going to become one set of parentheses. Okay. The stuff left over is going to become our other set of parentheses. 2x squared plus 7. And don't forget, we also had the GCF. That's part of our factored answer, right? It was the greatest common factor. So it has to be one of the factors when we're done. So that is our answer. The greatest common factor, and then our factoring by grouping parentheses. Okay, the last section here is just solving using zero product property. So remember, to use zero product property, it needs to be fully factored. So if I see something like f here, right, this isn't fully factored because I don't have two things being multiplied. I have something being multiplied here plus something being multiplied here, but this is not a product yet, right? I don't have two things being multiplied together. So this is actually just like our almost last step, right? So if I look back up here, right, it's going to look very much like this step, right, where we have a bunch of stuff in parentheses. So we're going to be looking for those matching parentheses. So that's all we're going to do. We're just going to kind of finish solving by grouping. So we're going to factor out the x minus 3. And we're going to use our leftovers, which is 2x plus 7, to make our second set of parentheses. But now we have this equals 0, right? So let's just refresh ourselves on how we use our zero product property. When we multiply two things and we get 0, we know that those two things can be 0, right? So we're going to set both of these equal to 0. So that's all we do, and then we solve our equations. So x minus 3, we have to add 3 to get x by itself. We get x equals 3. That's going to be one of our solutions. 2x minus 7 equals 0. This is going to be a two-step solution, right? So we have to subtract 7. So we get 2x equals negative 7. Divide by 2. And we're going to get x equals this whole answer here, negative 7 over 2 as our second answer. So x equals 3 and x equals negative 7 over 2. And our last, well, nope, we got two more examples. All right, so example G. Okay, remember, when we see these, we have to just look for the matching parentheses. So x plus 9 comes out. X minus 8 is left over. Equals 0. Set your two factors equal to 0. So x plus 9 equals 0 and x minus 8 equals 0. In this one, we're going to subtract 9 from both sides. We get x equals negative 9. These are both one-step equations. Here we're going to add 8 to both sides, right? We always do the opposite. And we get x equals 8. Okay, so those are our two solutions, negative 9, positive 8. All right, last example, same idea, right? Where do we start looking? That's right, the parentheses. So these guys should match when that happens. We factor them out. So x plus 4 was our matching stuff. 3x plus 5 is the leftovers. They each make a set of parentheses. Okay. X plus 4 equals 0. All right, that's our first one. And the second one is going to be 3x plus 5 equals 0. So x plus 4, we have to subtract 4 to solve that one. Subtract 4 from both sides. We get x equals negative 4. And then our second one is going to be a two-step equation. So I'm going to start by subtracting 5. We get 3x equals negative 5. Divide by 3, and we get x equals this answer, negative 5 over 3. Okay, one more example here. Okay, parentheses match x minus 2, 4x minus 6 leftover. Set equal to 0. Set both factors equal to 0. Solve. First one, I'm just going to add 2 to both sides. We get x equals 2, right? That was our one-step equation. Second one is a two-step equation, so I'm going to add 6 to both sides. And I get 4x equals 6. Divide both sides by 4. Okay, but we get x equals 6 over 4, but that one needs to simplify, right? So 6 over 4, we've been talking about common factors. 6 and 4 are both multiples of 2. So I'm going to cancel out the 2's. 6 divided by 2 is 3. 4 divided by 2 is 2. So we get 3 over 2 as our simplified answer. And that is your notes for today.